Hello, coming to the third episode on C programming. Now we came here with something a little more interesting. This time we will talk about variables and inputs and outputs of them. First of all, variables are memory regions where you can have values and change them, as opposed to constants that are values that you cannot change. The first type that I could mention to you would be actually the type that I used previously, but type that just means nothing. It's not that much interesting, but there's another one that has a concept that I will mention later, that is a pointer, and with body pointers you can do interesting stuff, so to speak. So you can see that I have a return type here that is integer. So it should have a value. Please by keyboard issues. So we have here the integer type that is about integer values like in math, but they have a limited range that is limited exactly by the amount of memory that is reserved to the integer type. Traditionally, the integer type has a size that is dependent on the processor length of the processor board. So if you have a 16-bit processor, you have a 16-bit integer. If you have a 32-bit processor, you have a 32-bit integer. This that I'm using here is a 64-bit processor. So by that convention, the integer should have 64 bits, but the convention seems to have shifted to keeping 32 bits to integers. To check that, you can have a variable and assign to it the size of an integer. You have this function size of that returns the size of its argument. So you have the size of integer in bytes, and if you want the size of it in bits, you should multiply it by h, that's the number of bits in byte. By the way, since this is still in a very introductory level, I should mention that a bit is the minimal unit of information in computer science. That is a value that can be either 0 or 1. So you have the size of an integer in bytes, multiply it by h, and you can output it this way. An int has %d bits. That sequence of letters here, %d, means that you must output the text in the way you can read it as an integer, because the way that C manages variables, in principle you don't know what is in this memory position. Memory position that is represented by X. So you can interpret it as many things. In the case you want it to be interpreted as an integer value, a number 1, 2, 3, 4. So there's another type that is the char type, that is meant for characters. Characters as in a letter in this text. In this case, we think of chars as values in the ASCII table. So the ASCII table goes from 0 to 255, 255. So 255 typically, and so it has 1 byte, that is exactly 8 bits. So what you should do here, the same thing you've done before. Alright, so you have again printf to say a char has % bits, and you can print this value. Now to test the char type, you can make a char variable C and attribute this A to it. And now we can play with that way that the memory space has value, and in principle that can be anything. So you can add to the char value, and that will move up 1 position in the ASCII value. So if you print it, it's as a character, like %C is to say that it should be printed as a character, should be displayed as a character in this text. And here we have the line break. So you have the variable C that is mapped to this %C. Now we can finally have some interactions to the user, some inputs from the user. So you can use this function called scanf, that is also in this library of input and output that we included in the beginning. So you have scanf %g, meaning that you read it as integer number. And you have this very interesting construction here that is related to pointers, concepts that I will handle later, but it's meant to write on the X variable, the X memory position. So it stores the user input there, and you can print it back. So let's test it to see what happens. This is a program, and it has 32 bits, a char has 8 bits, A and B. See that when you move up 1 position in the ASCII table, you move up 1 letter. So it started as A and turned up to B and B because it was incremented by 1. One thing that I might have skipped in here is that you have these recursive operations. So if you have a variable and you want to multiply it by h, you could do it x, again x, x equals to x multiplied by h, the value that x has to currently multiply by h. But there's this notation, you see, for recursive operations, that you can write the same thing like this. The same thing can be done here. And there is even another notation more simple to the same stuff. C++, that's funny enough, is a name of another language that is a texture of C. So you have this, but you obviously work the same way. But you spice it up with more types and more tests here. So you can have a float type, that you can guess by this is about rational numbers and about represented in a limited way the real numbers, which comes to show that there are some limitations to what you do in computers, but you can have quite a good approximation to the calculations you want, to the things you want to think with real numbers. So you can have that again. What if you want to display that value? that float value. So once you can test this, I think it will be enough for this episode. But there's of course a lot more we can do. Then we can explore some more types, and we can explore some operations, and after that we can start working with algorithms. Very simple ones, by the way. But if I go on with this, I plan to make it more and more advanced. So I hope to see you all on the next episode after I test this. Alright. Now it asks for input as it should. Alright. You can see it displays correctly the float value. You can see that it has more precision positions here, more digits. Now I see very clearly that we can do this again. By the way, we are doing this many times. There are things you can do to avoid repeating it yourself so many times. The most common thing that you can do is declare another function, so you can use it again and again. Now we can do this. Yeah, just stick this. It's a longer episode, so more mistakes can eventually happen. As you can see, the float type has the same size as the integer type, but in the float type there's a way to represent the rational numbers that relies on scientific notation. I can go and explain it a little more next time. So it's already a little longer video, but we are still on a very introductory level. Things are only gets more funny and harder going on. So this video is that you should do this. You can do this, and that's it. I hope to see you on the next episode.